Hello everyone, welcome back to this another video on R. My name is Lalit from Map Painters. So from today we are starting a new series on the data analysis using the R software. So this is the R Studio software. It is the IDE of R, and R is basically a programming language. So today I got a lot of requests on how to display the compact letter of any research on their respective graphs. So today we are going to learn how can we display the compact graph. So compact letter. So compact letter is something that uh, we get after we do the ANOVA and post-hoc test. So I have this data set of soil here. So I'm going to run this data set. So in R, when we read the dataset, we type our script like this. So I'm giving a variable name as df and read.csv because my file is in the CSV, and the name of this file, if I press the tab here, then I'll get this file swell.csv. So I'm going to select this and let me run this. Okay, then let me check the heading of this data set. So if you check the heading, so we have the replication, biofertilizer, and fertilizer. These are three factors, and then the others are the parameter like the plant height is 30, 60, 90, tiller numbers and spike length, and a lot of other uh, parameters are here. So let me clear this. To clear, simply press Ctrl and L together, and your output will be clear here. So first of all, in R, before doing any analysis, we need to assign the factor variable into the factor. So to assign any factor variable, we use this function as factor. So here I'm going to write df. Df means our data frame name. Then I'm going to assign this fertilizer variable as a factor. I will simply write as factor df, df dollar fertilizer. So this is my first factor. Then second factor is my replication. So I'm going to assign replication as a factor as well, because we are going to perform the one-way ANOVA. So we are not taking the third variable. I'm keeping that as a numeric variable for now. Okay, then so to perform the ANOVA, we do the GPRMA test, but our objective in this video is not to do the ANOVA, but to display the compact letter in our graph. So I'm simply giving the name this WACO variable name to the ANOVA, and in ANOVA I'm going to use this AOV function. So this AOV, it's saying that the PS 60, that is plant height at 60 days, is affected or by replication and fertilizer. So I'm going to give this plus sign, and I'm providing data as a df, which is our data variable. So let me run this, and let me run this summary. So in the summary, we can see that we had three replications. So degree of freedom is 3 minus 1 is equal to 2. We have 8 fertilizer from 0 to 7, and 8 minus 1 for the fertilizer degree of freedom is 7, and residual is 48. So you can see that the mean sum square is 4.6, and from this 3 star we understand that there is a significant difference in fertilizer. So after we run this ANOVA model, we do some post-hoc test. So in this for this session, we are going to use this Tukey test, but you can do the TMRT as well. So I'm giving this variable name as Tukey, and I'm running this Tukey test in our ANOVA model, which we provided the variable name as WACO. So let me run this, and once I run this Tukey, so it will give a lot of information here. So you can see that the confidence level is 95%. So this is the fit, and we can see that there is a replication. So replication 2 and 1, it has its difference on the lower range, upper range, and adjusted p value is given here. So likewise in fertilizer, there is a difference between T1 treatment 1 and T0 treatment 2 and T0, and like this we get a lot of information here. So before we move further, we need to load some libraries. And first one is this tidyverse. So if you haven't installed the packages yet, you can do that by simply writing install dot packages and you write the name of packages. For example, I'm going to install ggplot2, and once I run this, so it's saying that my ggplot is already in my system. You want to restart for the reinstallation. I'm going to cancel this, but if you haven't install the package, you can do that from code, or if you want to directly install the package, you simply go to these packages and go to install and write the name of package, for example ggplot2, and you can simply install from here. So I'm not doing that right now. Okay, sorry, let me clear this console. Now we are going to call another library called multi-comp view, and then the next one is dplyr, which is used for the data manipulation in R, and then the last one is ggplot2, which we are going to use for making some beautiful plots. Okay, so now we are assigning this compactlator. So I'm giving the name CLD variable name, and inside that we use compactlator 4. So there are different versions of compactlators. Like compactlators 2, 3, 4, I will use this compactlator 4. So inside the compactlator, we are providing the this ANOVA model. It has the variable name WACO, and then we are also providing this post-hoc test, and this Tukey test result are stored in this variable name is Tukey. So where I'm assigning this Tukey. Okay, and then let me run. So once I run this CLD, you see that there is a replication and there is a fertilizer. So in the fertilizer, you see T4, T1, and T7. These three treatment they got the equal or same letter, and there is a different letter in other treatments. Right. So if you want to learn how this work or what type of input it takes, you can simply go to this health option here. Then simply write multi comp. Okay, not multi, that's mult comp liter. Okay, if not here, then maybe you can simply write what mult comp letter for, right? Once you run this, you'll get this type of help here. So you can see the uses. His mult completers, it takes the x, right? Then compare to the threshold and it provides letters. Okay, so you can see the argument here. X is one of the following squares or a symmetric matrix with row names. It has given a lot of information here. Then you will see the letters, reverse formula, and others. So you'll see this type of example as well. So it will make help you to understand this in more better. So you can explore here. But the general idea is you just provide the ANOVA model and then the result of Tukey or our post-hoc test. Okay, then we are going to create a factor table here, and for the factor table, I'm going to store this in this WAJE variable. So here we are using the dplyr function. Sorry, here we are using the dplyr packages to manipulate the data. So what we are giving here is from the data frame. Okay, we are taking this fertilizer, which is our main factor. So and we are going to summarize mean of the plant height at 60 days, and we are also going to calculate the standardization of plant height at 60 days. So why we are doing this, we'll know in our plot making section. But here one thing we need to remember is that our mean value is stored in this W variable, and standard deviation is stored here in ST, and we are then arranging this mean, which is stored in this W, in descending order. So let me run this, and once I run this WAJ, you can see that our treatment 4, it has the highest mean 61.0, and its standard deviation is 1.28, and for the treatment 1, the mean value is 60.3 and standard deviation is 1.94, and likewise you can see the mean and standard deviation of all the treatment here. All right, so now we are going to extract or compact later. Okay, then we are going to add this to our table. So we have this table like fertilizer, mean and standard deviation, and here we want to add this letter that we got from our test here, like from the CLD. You can see that there is T41, T7, and we're going to assign this later in our next column here. Like we have fertilizer, mean, then standard deviation, and here we want to assign those later by giving some name of the column, right? Okay, now we are going to make one another variable, that is NLD. You can give any name to the variable as you wish. I'm giving NLD. So here I'm going to make a list of data frame from this CLD, right? This CLD. So if you check this CLD, okay, CLD and dollar. Once you provide dollar, then you'll get the name of other column stored in this variable. So in the CLD, there is two column, that is rep and fertilizer, right? Rep means replication and fert means fertilizer. So from here, I'm going to assign this fertilizer as a data frame list. Let me run this. And from the NLD, right? From the NLD, so in the WAJE variable, I'm adding another variable as CLD, right? Or let me give dollar and see WAJ, there is no variable as CLD up to now. Like there is fertilizer, W means mean, and S, but we are going to give another column there. So the name of column will be CLD. And from this NLD, we are going to assign this letter here. Okay, let me run this. And once I print this, you'll get this type of output. So there is fertilizer, there is mean weight of planted 60 days, then there is standard deviation, and there is CLD, that means our compact letter, right? So we did what we wanted to do. So let us ignore this code. Sometime our R might consider this mean weight as a factor. So here I'm going to changing this into numeric, but I'm not running this code right now. Let us check first. Okay, we're going to making some plot using the ggplot2, right? So in the ggplot2, I'm assigning this ggplot2 graph is into this variable called p, right? So let me go here and let me clear all of this. Okay, so let me explain this to you. So we are going to make a bar plot here. So I'm removing this plus. So let me run this, and maybe I'll run this p. Okay, so this is ggplot2. So function called ggplot, and in the ggplot we are providing a data frame. The name of our data frame that contains compact letter is WAJE, not DF. So WAJE, then and inside statics we are providing X as a fertilizer. So where you can see in the x-axis there is the name of fertilizer. In the y there is a mean of the plant height at 60 days, because this W means mean because we assign W as a mean here, right? So in the fill, we are going to fill the color with this mean value. Okay. In the R, you need to write plus to add anything, any other things in this plot. So I'm going to write this plus, and then I'm going to define which graph I want to plot. For example, I want to plot this bar graph, right? So in the inside the bar graph, we need to provide this stat is equal to identity. Okay, let me run this, and once I run this p, so you can see that. So this is a bar graph which has fertilizers name in x-axis, the mean weight of the plant height is 60 days in y-axis, and there is a legend as well, right? So let me, I don't want this legend, so I'm going to remove this legend with the code so that legend is equal to false. So if you want to keep, you by default it's true. If you give this false, the legend will be gone, right? Okay, then the next thing we want to add is the bar. I don't know what is it called, error bar. Sorry. So next thing we are going to add in this graph is error bar. So I'm going to write geom underscore error bar, right? So in the error bar, we are going to provide static. So y minimum value in the error bar would be mean minus standard deviation. Remember, mean we have given the name as w, so w minus standard deviation, and y max, right? W plus standard deviation. Okay, let me run this. Okay, you see we have successfully added this error bar here, and I'm going to provide the width of 0.2, right? Let me run this. So error bar looks pretty good now. Now let's add another thing that is called labs. So the labs in R are nothing but of a function where when we can add like x-axis, what is on our x-axis, what is on our y-axis. So if you see this graph now, you don't understand what is this 40 and what is this w. So we are going to provide the x and y-axis level here. So first we are going to provide the title, right? Title is our effect of different fertilizers in plant height at 60. Okay, DAS means in days after sowing, right? And then we're going to provide x is our fertilizer dose, maybe kg per hectare might be its unit, I don't know. Then y, this is the mean height, right? If you, so I'm going to write average plant height at 60 days. The unit is in cm, so I'm going to write this cm. Let me run this. Now you see that we have our nice level at y-axis and x-axis. We also have this title at the top. Okay, so we did this. Let me remove this. So why I'm writing this again is to show you the process, because if I run everything at the once, it might confuse you. So I'm writing this again, right? Then I'm going to add this again, and okay, maybe let's add some geom text. So geom text are so in the geom text we are going to provide those level and that we calculated earlier, right? So geom text also we are going to provide this aesthetic, and inside the aesthetic, so level is equal to CLD, right? CLD, then y label y is equal to W plus SD, right? Let me run this first, and you see we got this letter printed in this error bar, right? So we need to adjust those letter because they are overlapping here. So v just, right? I'm going to use this v just is equal to minus 0.5. This is a hit and trial method again. So start from some 0.5 or minus 0.5 and then adjust accordingly. So if I give 0. Minus 0.5 in pieces, that is vertical adjust. So my letter perfectly fits here, right? So I don't need to change anything. If you want to make your graph smaller, you can give this y limit. So for the y limit 0 to 70, okay, it will slightly reduce the size of this bar, right? Then again plus, so don't miss this plus. If you miss the plus and on the code, it won't work, right? So inside the plot, there is something called scale underscore fill gradient, right? Fill underscore gradient. I don't know what it takes. So I think it takes some color. If the low color is value is low, then you can give some color. If the value is high, you can give another color. Yeah, it can be seen here. So I'm going to leave it blank because the low value it has like very dark blue color, and the high value it has some light blue color, right? Okay, what it is saying. We can do the plus. Okay, nice. So, and then there is something called theme, right? So there are different type of theme. Like I'm going to use this classic theme. It will change the background color. So you want to, if you want to change something else, bright tab, and there is dark. If you run, your graph will look like this, or maybe you can try something else like gray. It will look like this. Okay, and that's how you make a good bar graph that shows your letter, compact letter, and this error bar as well. So there is many more to explore in the ggplot because ggplot is a huge library. You can do anything you want. But this is it for today. If you want to save this graph, write this save and give the name to the graph, and width and height. But I don't prefer this way. So to save the graph, I do is go to this export, then save as image, and then give some name like PS60, and then you can simply save this. Right, so this is it for today. Thank you for watching this video. If you like this video, make sure you subscribe to our channel, and if you have any confusion, you can just comment, or you can just DM me in our LinkedIn or Facebook. So in LinkedIn, the name of our page is Map Painters Spatial Research Lab, and the same name is in our Facebook as well. So go and give it a try, and if you got confused somewhere, just let us know by the comment, or by the text. And we frequently do some training sessions on data analysis or GIS and remote sensing. So if you are interested, you can apply that as well. So you can check our website www.mappainters.com, and I'll see you next time. Bye.